Hello and welcome to this talk. It's a pleasure for me to see you here and what we want to talk about today. Today we want to talk a little bit from supply chain security about what it is, where it is for the software development and going down to malicious packages. And if this is something interesting for you, then you're right here. By the way, my name is Sven Ruppert. I'm developer advocate for JFrog and I'm specialized here for DevSecOps and cybersecurity stuff. And if you like this style, have a look at the YouTube channel, the JFrog one, where you can see more videos about these topics, or my private channel where you can see IT related stuff here straight in the woods. So, but now, time to start. So let's start talking a little bit about the supply chain. Supply chain security means that the whole supply chain with all their individual points over company borders has to be secured. The big companies mostly investing so much money in security and protection that the pressure is not against the big companies anymore only. It is more and more against all these tiny parts left and right. But what does it mean for a software developer? I mean, supply chain security itself is a very broad topic, but now I want to focus just on the software supply chain, so from code to binary, what is running in production. So let's discuss a little bit what are the attacks around or along the supply chain. So as I mentioned, I want to focus on the supply chain just for software developers from source code up to the binaries. And mostly what attacks we have the possibility to bypass code reviews and so really to modify the source code itself. It could be done by official ways to get source code in by colleagues that want to compromise something, whatever. So the next step is now this code is inside the source code repository, and the source code repository for sure can be compromised, so you have to harden this one. After this code is inside the source repository, we have now the next component that is building this stuff. So you have the CI server. And from source code repository to the CI system, you have different ways to compromise, to attack the system. It could be that you are attacking the CI system itself, so you have to harden this, or you can bypass, for example, that you are grabbing source code but overlaying source code, so that the build service itself is just using wrong source code. And then inside this one, if you have built inside the CI system the binary, then it's time to push this binary to the repository. And here again, you can bypass the CI system to push something in the repository, some compromise binaries. You can just compromise the repository itself so that you're changing stuff there. Or you have two things that are more or less coming from outside. And coming from outside is something like a bad package that is just something that you're grabbing, but it's not really what you think it is. Or it could be a dependency that has some vulnerabilities. And with this, we have a very broad way to describe it. And there are two Linux Foundation projects that I want to highlight here at this point. The first one is SLSA. And SLSA is giving you an overview and documentation about best practice and different stages where attack can happen. So it's a documentation project. And an implementation of parts of the supply chain security for open source project is a project Persia.io. And in this project, there's a decentralized package management that's addressing some of these attacks like compromising the repository. So these are two big projects. So SLSA is a Linux Foundation project as well as Persia. And have a look there if you're interested in this more generic one. But I want to focus now on some things, and this is everything that is coming from outside. And you have two things, vulnerabilities and malicious packages. So one thing is now, if you're looking at these binaries itself, so everything that's coming from outside, so back packages or vulnerabilities in dependencies, so what does it mean? We have to decide a little bit what is the difference. So we have, for example, intentional and unintentional vulnerabilities. Immediately, if a vulnerability is known, a toolstack like X-Ray, for example, is able to scan all the binaries, detect this vulnerability, and can highlight this, plus additional information. If you want to try out this one, go to jfrog.com. We have this free tier. Inside this free tier, we have X-Ray. And X-Ray is a vulnerability scanner where you can just say, scan this Docker image, scan this jar, scan whatever you need there inside this repositories, and you will get a list of known vulnerabilities. But known vulnerabilities is one thing, malicious packages is another thing. But what is the difference, or what is a malicious package? Let's talk about malicious packages, and we have different aspects I want to highlight here. And the first one is the infection methods. So what is an infection method? So the way how this malicious code is provided, or it's provided in a way so that you're consuming it. I will start now with type squatting. So what means type squatting? Type squatting means that you have common packages, very well-known packages, and they have a name, and you're grabbing this code, and then you are changing the name of this dependency based on common typos. And then, if you have a common typo, you're just providing this package in a regular official repository, and then with this typo, he's just referencing a corrupted package, and inside this package you can do whatever you want. So the next thing is masquerading. So masquerading is focusing on imitating the whole environment around a dependency. So you think you're duplicating the code, the metadata, you're adding small pieces of malicious codes here inside this one, and you're building Trojan packages. So you're building something that looks exactly the same, that maybe has a same name but provided at different places, and then something is inside so that you're infected. That's it. So the only difference from the original package is maybe one line with an obfuscated code that is doing something, calling something, sending something, and so on. The next thing is a Trojan package. A Trojan package is more or less like the historical view. You have a package that's doing something, a PDF library, and it can print and all this stuff, so everything what you need. But inside this you have additional functionality that's obfuscated, hidden somewhere, and it's just activated during the time you're using this really well working library. So sometimes these Trojan packages, they are good libraries, so they're giving you a good value, but an additional value as well. Another way is dependency confusion. Dependency confusion means that you if you have internal packages and external packages, for example, so inside your company, and I know, for example, because I know someone who's working there, or this information is bleeding out, I know what is the name of an internal dependency. Then what I can do is I can create a dependency exactly with the same name and a higher version number, or a very high version number, and putting this one in official repositories. So I'm really using exactly the same definition, but my CI environment is looking first maybe at Maven Central and grabbing there this wrong dependency with the same name, maybe same functionality, slightly different version number, so that automatic version increases will grab this one from outside, and then you have this dependency confusion in a way that you see it's my dependency, but it's grabbed from outside. Another infection method is hijacking. Hijacking means that you have access to the infrastructure of this project. You are taking over the ownership in some way. It could be in an aggressive way that you're really hacking the page, having this, or if there's a non-maintained project and you see it's used, then you're just taking this free domain and building again something around it, or you're taking the open source project that nobody is maintaining anymore and doing this one. So hijacking is, it's more or less you are the maintainer of the project, but with a different intention. So these are the common infection methods. And now the question is, what are common payloads? Another thing is, what are common payloads? Common payloads is more or less what they're doing. So what is this code that is in these malicious packages? And then one of the bigger things is sensitive data stealer. So it means they want to have credit card numbers, they want to have user tokens, environment variables, passwords, usernames, whatever. So they want to steal this data and sending them somewhere. So you have this, okay, look, if you have this environment variable, check this name, and with the next request, send an additional request to the attacker server. So that is one thing. The other thing is that you have something like a connect back shell. It's like a remote shell. So there is malicious code that's waiting and connecting back to the attacker server so that he knows, okay, this malicious code is there, I can connect, then I'm sending commands, it will be executed on the other side and the result will be sent back. So this is just, whatever you can do at this system to do this one. And another thing that is very popular these days is that you have download and execute. So you have a malicious code that is connecting to a remote server, downloading a binary and starting executing them. And this is quite often used for example, for crypto mining. So just to mine cryptocurrency with other people, energy and money, and sending this one back. So these are the most common payloads that you have in malicious codes. But how to hide this malicious code, and then we are talking about obfuscating techniques. Now, talking about obfuscating techniques. Obfuscating techniques can be just by public available obfuscator or custom made obfuscator, but mostly you can really search for obfuscators and then you're using it. So what they are doing is more or less they're renaming variables, they're encoding commands in different encoding and all this stuff, so that you are not able to read it immediately. So you have to re-encode it to see what's going on. So this is one thing. But a little bit more interesting is a control flow flattening. The control flow is more or less, you have this control, so it's running A, B, C, D, E, F, G, and then in the middle you're breaking some if then else stuff in, and then depending on the amount of calls or variable or whatever, different code will be executed. And this is so implemented in the code that's not obvious, so that you're not really immediately seeing it. But if you're analyzing the whole control flow, you will see that there is something that is around this main logic. Okay, the next is homoglyph characters. Homoglyph characters is something like you have this different Unicode character that are looking like plain ASCII Latin characters, but they will be different if you're comparing strings and all this stuff. So with this you can make sure that some comparisons always succeed or always fail. So for you it looks like a regular ASCII sign, but it is a different Unicode sign. And with this you can do a little bit more, and this is this bidirectional control characters, and this is a cool thing. So we are reading left to right, right to left, whatever, and we can say it to the machine as well. And we can use this control characters inside my source code, so that a human is reading maybe from left to right and seeing, okay, this is in source code, here's a command, it's sort, it's end, and so on. And the compiler will see it completely different. He will come to this character, switching from left to right to left, reading and interpreting this stuff, and it's completely different. And this is something that is quite cool in terms of getting this understanding for this, but it's not so easy to detect. So, big question is now, what can you do to detect malicious packages? So, it is more or less, first of all, you can use tools like X-ray that are scanning and identifying the known malicious packages and vulnerabilities. So in the end, for you as a developer, what you can do or what you should do, you should scan all dependencies that you are using and generating. You should block all, for internal dependencies, you should block your repositories that they are not fetching the same dependency from outside, so that you're sure that nobody is delivering from outside your own dependency. And you should create something like an SBOM. In X-ray we have this build info, it's collecting all the data about the dependencies and the environment variables and all this stuff, so that you can analyze it later. And on the other side, a lot of projects already have the requirement of generating an SBOM, the software bills of material, so that you have this complete list of dependencies we are using, so that you can identify what is used, and if there's something, even after you build it, so that you can identify, okay, there was something in, and you can immediately react to this one. If you want to have more information, feel free to check out our webinars. They are way more detailed, or you can attend one of my webinars and workshops about DevSecOps, or how to deal with tooling, how to identify this stuff, and to prepare yourself. So feel free to contact me. LinkedIn, Twitter, whatever it's best for you, whatever time is on your side. I hope you have a good rest of your day, and I hope you enjoyed it. Stay safe and see you.